So I'm going to turn this around to set up the computations, and then we will take a look at it. So I'm going to do A. Here we're going to introduce a couple of concepts. First one is the output specification. Oh, my handwriting's terrible. You know, when I was like in grade 7, I got the award for most improved handwriting. I went from an F to a D+. I think I've stayed at the D+ level forever. But I actually try. So when I'm writing this on the board and I'm doing the letters, I'm actually thinking, let's try and do a good job. But somehow, I guess, you know, there's some brain problem going on here. So output specification is important. It's related to that realization rate. You have to know what you want to have in the product. Okay? So in this case, we're making a 5-gallon container quick kill, and we have direct material A. We need to know what the engineers or designers say about the direct material A and how much direct material A should be in that 5-gallon container. Okay? So we need the output specification. Okay? And so we're working on the standard quantity right now. So if we look around, in fact, it's labeled in this problem. Some problems it's not actually labeled. You have to read the English to see how much direct material A should be in the final product. So that's a huge distinction because there's always going to be some loss rate. Not always. So there are a couple of problems in this book where there is no loss rate. What they're doing basically, there's a problem later in the book where there's no loss rate for direct material because it's a really big, ugly overhead problem, and they just want you to walk through it for a little lightweight practice on the direct material and direct labor, and then you hit the overhead, fixed and variable overhead and mess, and it's tough. So you will see no loss rate in problems where they're just trying to focus on something else. Other than that, there's always going to be a loss rate. So if we look at this, in this case, it's a first problem in the book, I think, that talks about this, so they're being very specific. They're saying that inside the 5-gallon container of quick kill, you want or need to have 6 pounds of direct material A. So you need 6 pounds direct material A. Notice I didn't just say 6 pounds, I said 6 pounds of direct material A, because direct material B is also done in pounds. And if you do not label this unambiguously, one, you're going to get lost. Also, I am not going to give you partial credit. If I can't tell which one you're doing by the labeling, I am not, there's no partial credit. And actually, if you have it unlabeled, there's no credit. Huge part of this is document, 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 document. Okay, so we got the 6 pounds for direct material A. That's our output specification. And we need to take a look at what our realization rate is, and they don't give us that. They give us the loss rate. And they are using we have to penetrate the language, allowance for waste. So they're telling us how much we think, or we're sort of mentally setting aside for the loss. And they're saying that it is actually 5%. But we need the realization rate. We need the percentage of good stuff that happens, right? We need to transform the loss rate into the realization rate, and we do it like this. 1 minus the loss rate, meaning 100%. 1 meaning 100% minus the loss rate. Where you can get hooked sometimes is in some problems they won't give you the rates. They'll say, we're going to lose 1 kilo of inputs for every 25 kilos. That we put into the process. It's up to you to compute the loss rate. They'll do that a little bit later. Once they think you have the general concept, and they'll start making it a little bit more challenging for you as you go. So if we do the arithmetic here, this is what we actually have to put down as the standard quantity. 6.3158 pounds of direct material A per 5-gallon container of quick kill. Okay, so over here, $6.3158. I just did these numbers from memory. I think it was 3.3158. 6.3158. Notice you can fill this in. Now you're okay, and you have documented your computation somewhere on your page with this. if your handwriting is good, some students are always very effective at this. They actually can put it right here. That's fine, okay? Just try it, have everything blocked out and labeled, and put a little box here and show the pieces with the correct units on it, and you can do that fine. If you have enough space on the page, like if you're only asked to do a couple of lines, you'll have a lot of space. You can do it. So even though this has to look like a statement, because it is an exam in a class, you can block out an area, and if you draw a line around an area, I will assume it's not part of the statement. It's part of your work area or your computations page, in effect, okay? Because this would be computed on a computations page probably, because it has important pieces on it. Even though technically you could compute this in the spreadsheet, there's an idea here that's important, which is this. When you do this and get the realization rate, that's an important separate concept that we would like to see when we're doing our analysis. So we would want to reveal that separately. If you put all of this in just one formula, then you're never going to have the concept of realization rate that someone can examine and see separately. Okay, let's take a look at this was the standard quantity. Now let's look at the price. This is the So we're going to look at the standard purchase price. Remember, we're going after dollars here for purchasing, and they tell us that we pay $3.50 per pound. Okay, this is the traditional accounting way to do this. Don't do this. When you're doing really technical stuff, when you're not doing an accounting statement, but really doing analysis, don't use this accounting form of describing your units. Use the scientific form to keep the units together. It's going to reduce ambiguity, and it's going to reduce the number of errors you can make later. So it always, also in your mind, you can always think of this as dollars per pound. Okay, so anytime you're doing any analysis, don't do the disclosure type of notation. So we have $3.50 per pound. Notice they're throwing us a few hooks here. We get a purchase discount, and we have a delivery cost per pound. So we're going to take the purchase discount minus, what is the purchase discount? 10%. Minus 0.9, or multiply by 0.9 and delete the minus sign. Notice you can do this other ways. You could compute the purchase discount separately and subtract it, but I know that multiplying by 0.9 is the same as getting rid of the 10% purchase discount. That's going to give us $3.15. Notice I'm putting the units again. I am still following the accounting method of display, which is really useful for everything, not just accounting, is everything here. This is a row, this column, and this column. Anytime you have a line, you're assuming that the column is broken, and you need to precisely identify everything above and below. And we can identify everything at the top of the column. Remember, this 0.9 is technically a dimensionless number, so it doesn't need a units designation. And here, because the column is broken, I re-identify everything below the column. $3.15, and we have an 85 cents per pound. So not 85 cents, $0.85. And I'm not, because it's in the same column, I don't need to re-identify that. And that's going to give us $4 per pound as our standard price. Okay, so back to the spinning deck. We have $4 per pound as our standard price. So when we multiply that across, we're going to get 2526. Although that's actually not the correct answer. Your textbook makes a big mistake, and it actually rounds or truncates that number. In order to document your answer, you really need to take it out to the same 4 decimals you started with. We then, in standard costing, pretty much the minimum number of decimal displays you see is 4 up, and you could see up to 8. Because if you're going to be making 500,000 or 1 million products, guess what? That 6th decimal place is more than your salary. You know, that the 6th decimal place could easily be a $150,000 difference. You don't want to round off and just ignore $150,000. And I have my notes here, and you know what I did is I ran off the end of the page so I don't actually see what the correct answer is. That was not good. 6.3158 times 4 is 2632. So this is 2632. So at least 4 decimal places in this class and 4 exams. You can do more if there are a few more, but 4 would be, you can round, you're permitted to round to 4 in this case. Okay? Like I said, in most places that use this, it would be the least I've ever seen is 4, and I have seen up to about 8 decimal places, depending on the volume of what's going on. Okay, so that was also another thing that happened. Some people actually used rounding functions in their spreadsheets, and everyone that I looked at, I caught, because that's a big no-no. You never ever round anything, because that rounding is actually going to create an error that cascades. And if you use that number 5 extra times, you know, in different places, that actually can round up to be like a pretty big difference in what your final answer is. If you only want to show two digits, use the display functions. Format the cells so it only shows 2. Okay? Don't ever round, don't ever truncate, you know, don't do any of that stuff unless it's, in some cases, maybe legally mandated, or in a tax code, they say if they tell you to do something, you do it. Other than that, keep the number intact. Change the display if you want, but don't change the number itself, because in a lot of real world cases, that 3rd and 4th decimal place, like, it's $150,000, $200,000, even bigger money than that. You know, if you're building, you know, if you're bidding on a contract to build a building and you're looking at like a $50-60 million building, the 4th decimal place could easily be $400,000. Okay, so don't round. In this case, for this class, 4 decimal places here, even though shamefully I didn't do it myself, because I actually ran my notes off the page, and the book didn't do it because they're a little bit old-fashioned. So we're going to get into the practice of doing that. So that's it. What I think you should do right now, you've seen the model that I did. On the other side, you had it. Hopefully you've written it down on your page. Stop this recording, and you do direct material B on your own without looking. Oh, you can. Don't look at the book solution, but it's fine to look at what the model that I've shown you and try and duplicate that and get your answer, then check with the book solution. Okay? I'm going to now roll and do the direct labor because it uses a slightly different approach. It's still the same logic, but you know, because of the features of direct labor, we do it in a slightly different way. Notice that we know what we're looking for: number of direct labor hours per 5-gallon container of quick kill, and also dollars per direct labor hour. So let's flip this thing around, and we'll look for each of those pieces. This is also another reason why, oh God, why I wish I was in Terre Hall, is because, you know, it's really good to look at these things simultaneously so you can glance back and forth and see the whole layout. And this is one of the weaknesses, of course, of PowerPoint is, you know, you can't see basically more than a couple of things on the screen at once. So I hope you're taking notes on paper and you have it lined up, sort of going down so you can see everything I said are in this lecture. Probably on 1 sheet of paper, maybe 2, but you can look at the whole thing at once while you do that. So I'm going to erase this, even though we're following roughly the same model. One, we're going to have the output specification for labor and the same kind of concept of the realization rate, and then we have to build up the price of direct labor. So let's get rid of this, and get rid of this, and look at the slightly different story behind direct labor of how they tell you things. So let's look and see if we can figure out the output specification of direct labor. So we're going to do the output specification first. So how many hours, because we're buying direct labor by hours, how many hours of direct labor from Department 1 are in a 5-gallon container of quick kill? Notice I said in, meaning that was metaphorical. We say the labor is in there, even though it was not maybe in there. Okay, so our answer in here still has to be dollars per, or direct labor dollars per 5-gallon quick kill. Direct labor dollars from Department 1. for a 5-gallon container. Quick kill. Let's look down at Department 1. Estimated hourly wage, fringe benefits, downtime per day, standard cost lines for allowance for waste. And, so look at the text. It says 1 container of quick kill requires 1 direct labor in Department 1. That's the output specification. So what we have is 1 direct labor. I should do this in a slightly different size. This should be 1 hour of direct labor from Department 1 per 5-gallon container of quick kill. Now we need to see what the actual, what the realization rate is. And we're going to look at the facts that we have. If you look at what we have as downtime, basically we have 15, 15, and 30. So we have actually 1 hour of downtime. We have setup, cleanup, and breaks. And that's time that we have to pay for in all cases. So we are actually we have 1 hour for every 8 hours that we pay for. We actually have 1 hour that we don't get service. So we're actually getting our loss rate is 1/8, which is 12%. You'll know that after doing these problems for a while. And so the realization rate then is the 87.5%. And you can figure that out by looking at the pieces. So the loss rate here is 1 minus 1/8. 1 hour over 8 hours. And if you work that out, it's 1 minus 12.5%, and that is equal to 87.5%, 0.875. Okay, so we have 1 hour divided by 0.187, and that will give us 1.1429 direct labor hours per unit. Let me look back at my notes because I already forgot what it was. 29 DLH, direct labor. Oh, I put dollars here. That's a mistake. Direct labor hours, Department 1, per 5-gallon quick kill. Okay? So notice the computations are there. And in just 1 second, I will flip the board around and we'll put the equation up.